Yeah.
Okay. So for Lasso, as we mentioned earlier, the loss function that we described is the sum of squares of errors plus some lambda times absolute the L1 norm of beta,
Right.
which if I write down the expressions looks like this. Sum of squares of the errors plus lambda times sum of absolute value of the beta is.
Yes.
Okay. Now one comment. So suppose your data had 10,000 points and maybe 10 regressors. Okay.
Okay.
So then the first summation is 10,000 values of I.
10,000 values of I. Yes. Okay.
And the second summation is only 10 values of betas.
10 values of betas. Yes. Betas. Yes.
That automatically tells you like what choice of lambda would be reasonable there. Like some idea of if your number of data points is very high, accordingly your lambda has to be adjusted a little bit here. Because otherwise the sum of squares of 10,000,
Will be
suppose
so big.
10,000 chose to billion, then the first sum of squares will be much,
So
much
big.
higher.
Much, and then the other thing won't matter then at all.
Yeah, the thing won't matter. So you should adjust your lambda accordingly.
Yes. Okay.
Okay. Alternately, what people do is do 1 by n summation in the first part and 1 by p summation in the second part.
Oh, okay. Kind of
Okay.
normalize
So
it.
that's another way. So none of these actually changes the results, but you should know what value of lambda when you are choosing. Then these things comes into picture as well.
Okay.
Okay. Now, do you know about there's something called dual problems in optimization?
Dual problems. I'm not
Okay,
sure.
no, you haven't got. So there is some theory by Lagrange where you discuss about Lagrange multipliers and stuff, which basically says that minimizing this quantity is same as solving this problem, where you minimize the first quantity subject to this summation being less equal to something. Okay.
Okay.
So this is a mathematical result we are going to use.
Where did T come from? What is T?
Yeah. So T, what is T is not very clear. It turns out that T depends on the lambda thing. So instead of having a lambda summation thing, we have this less equal to some T thing.
Okay.
And different values of lambda corresponds to different value of T.
Okay.
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 So the intuition behind this is that instead of adding a penalty, rather we are trying to ensure that the none of the betas are very high. So sum of all the absolute of betas, we are giving a restriction on that.
Okay.
So
Okay.
that's like a different interpretation of the reach.
Okay.
We could have done the similar interpretation for sorry, we are doing this for Lasso, but we could have done this for reach also. That you minimize something, but put some restriction on the betas. And here the restriction is sum of absolute is less equal to some constant.
Okay. Okay.
Okay. Now, if this p value is, you can what you can do is you can do the full linear model regression for the least squares and calculate how much the sum of betas comes up to be. If t is something higher than that, then basically the linear model, the least square answer will be same as the Lasso answer because that then this restriction doesn't have any impact.
Okay.
Is making any sense?
No.
Okay. Let me break down into steps. Okay. So suppose you have a linear model and you did some least squares, right?
Okay.
So now suppose the coefficients are like one is some plus million, 1 million, another is minus 2 million, and all that.
Restriction
You
up to
don't
the
like
part
that.
where you're saying you're putting a restriction on not having a
Yeah.
beta coefficient go to. That makes sense. The last part doesn't make sense at all.
Okay. So we want to put some restriction. Now suppose your linear model end up with something like this plus 1 million, minus 2 million type of coefficients.
Okay.
So then the lasso will try to correct for that.
I got that.
But if the coefficients are already plus minus 2, 5 or something like that, so not very large, benign numbers,
Okay.
then the Lasso answer will match with the region, with the ordinary least square answer.
Oh, yeah. Okay. That makes sense. That makes
So
sense.
that's a good property to have. Like
Yeah.
if my answer is already good, don't touch it.
Yes.
But if
Okay.
the answer has some problems, correct it.
Okay. So lasso, the literally the purpose is for your beta coefficients to not be too large and take
Yes.
over. You have some way to
Yes.
lasso them. Okay, got it.
Somewhere to Lasso them. Okay.
Got it.
So you basically control it. And then different values of t you will give
Can I
you
ask a question,
or
Sujay?
Yes,
Like
yes.
in the history of data science, was this
Yes.
also like a progressive thing that was like developed slowly? Like linear regression was first discovered, and then like some
Yeah,
years.
yeah, definitely. So
uh,
linear regression is around 1800 because some scientists were trying to find some asteroids. Okay,
so trying to
that's the
find
story.
what?
Finding some asteroids.
Oh,
You know,
asteroids,
asteroids.
like
Yeah,
the
asteroids,
outer space. Okay.
cities and all. Yeah, so those were first discovered, and then people